Hello, in this video I'm going to make an application which act like an oscilloscope and captures the signal. For making a signal capturer, I need an ADC to read the signals from input pins. And for triggering the ADC, I need a timer to trigger it. So these two components are essential to design our signal capturer. I set timer 2 for this project and ADC 1 to capture the signal. Timer 2 counts periodically, and every time timer 2 period elapsed callback happens, it triggers the ADC 1, and in fact it calls the ADC 1 based on interrupt. So the data is called from PA0 into input 0 channel of ADC1. After completing the conversion of ADC1 conversion complete callback will happen, and after that we can perform an operation to capture the signal. In capturing signal, we need to get the ADC value, which we have in ADC1, and also if we need, we can perform FFT conversion. By performing this operation, we have a data to show it on the screen, and every time the handle tick event happens, show signal function and FFT show function will happen, which their duty is to indicate the data which have generated by capture signal in the touch screen. To make this project, we need at first to go to Touch GFX Designer and make our project based on the template of STM32F429I-DISCO board. I have this one, and I make the project based on this board. Its design is not very difficult, it's easy. You only need a dynamic graph on the image and put some buttons or toggle buttons. Then we can define the interactions for the buttons and also the toggle buttons, and this is the topics which has discussed independently, and you can find the related videos on the YouTube to learn how to design by Touch GFX Designer if you want. However, the interactions need to define the triggers, which is caused by the button select, and the name of the buttons. For each of these buttons, we need to define the interactions, and determine their actions, and determine the name of the function which we are going to call in the C++ program in our project. However, after designing, which is discussed previous, we can generate the code and then we can open our IOC files and the STM32CubeMX file and try to initialize our hardware. First of all, we need to initialize ADC1 active input 0, and in parameter setting type we can determine its 12-bit right alignment and disable these modes, and also select the POC flag at the end single. And for NVIC setting, we can active or enable the interrupt. After that, we need to active timer 2. For this, we are going to timer 2 in timers, then set internal clock for clock source, determine the prescaler with desired value and the counter period, and select update event for the trigger event state selection. Then we can generate the codes and then go to TouchGFX Designer again, and in TouchGFX Designer we generate the codes again after we generate it in STM32 CubeMX. And now we are ready to open the project in STM32Cube IDE. Before that, if we want to use FFT, we need to install RMath for DSP operations, which I've already installed it. In the project, which I have made it in the driver C TouchGFX project, Oscilloscope 8, STM32Cube IDE. I can open the project, which I have already done it. Then there is I made a header file, oscilloscope.h, and included STM32FX HAL and the RMath to perform DSP, because I want to calculate FFT for signals, determine the length of samples, the handler of the timer 2 and ADC1. I define them. I define in this project I perform CFFT and RFFT calculation for FFT, which is real FFT and complex FFT. To perform them, we need some arrays. I define them. Note that the length of the CFFT array is FFT length multiplied by 2, because the complex number is included in this array 2. Then I define the sampling variables, for example, the ADC data buffer, which is going to save the captured ADC value, maximum value, and maximum index of the which indicates the maximum value of FFT and its index, and a tick counter which is going to say is kind of counter to save the captured value. And I have two external variable which which have defined in the main.c. The main.c there are some variables here. In main.c I have defined some ADC variables and FFT variable. ADC value, FFT data, FFT length, ADC completed, and FFT enabled. Some of them are used here in oscilloscope.h, so I define them here. And I have used some functions. First of all, I need to initialize all oscilloscope with the timer and the ADC units. ADC units and timer. ADC and timer is initialized. Then I can start. For start an oscilloscope, I need to set the counter to 0 and start the timer 2. Start the timer 2 or timer OCS. For stop the oscilloscope, I need only to stop the timer 2. To capture the signal, I only need to use Hall ADC get value and get the value of ADC1 into the ADC value variable. And based on the value of FFT enabled, I can perform FFT conversion or not. If FFT enabled is true, then I can perform FFT conversion. Otherwise, it's not necessary. And for FFT conversion, I have used two functions, FFT conversion using CFFT and RFFT. Just take a look at the CFFT, complex FFT. I capture the samples in the ADC data buffer until the for a special length which is 256 here, and after we have a full array of the samples of the ADC samples, then we can perform the FFT in this section. I have defined this instance and initialize the input array with real section and imaginary section. Imaginary section is 0 and real section is the value which I have read from the ADC unit, which was stored in ADC data buffer. And I need to calibrate the value, because the value is between 0 and 496. Then I initialize the instance and perform CFFT to fill the output with the magnitude of the function. Then I can find the maximum value of magnitude and its index and perform a calibration here to get the value between 0 and 1 in our array and store them in FFT data, which FFT data periodically showed in the FFT show on the dynamic graph 1 and multiply it by graph scale. However, when handle tick event happens, which we have discussed here, if FFT enable this true, then we only use FFT show, and if FFT enable is false, then we only show signals. Only show signals just indicates the captured ADC value after calibration and show it on the graph. And FFT is indicating the FFT data, which I have discussed in this H5. In the main.c file, I have included the oscilloscope.h, and as I said before, we have defined some variables here. I initialize this value here. This value is 0. FFT enable is false. We only need to show the samples. ADC completed is true, which is used to ADC conversion, which I going to talk about it later. And this is the FFT length. After that, I initialize the oscilloscope and start it. Okay. Then we take a look at the TM period elapsed callback, and for timer 2 we perform this operation. If the callback is related to timer 2, I need to call the ADC1. So I said that if ADC completed, this means that ADC ADC completed before. I said I make it false and start the ADC based on the and then start the interrupt. And in the Hall ADC, I have this operation. If it is ADC1 callback, conversion complete callback, then I check if it's false. I perform a capture signal, which is here, capture signal, which get the value of ADC and perform FFT conversion in the oscilloscope.h and make the ADC completed too. And this happens periodically. Okay, I compiled and debugged it on the my discovery board, and I have my signals here. Before that, I make a signal generator and I fit my ADC with that signal generator, which comes from PA5, which I've described the mechanics of the signal generator later. However, we have a periodic signal here, and I can perform an FFT by toggling this, and as you can see here, by toggling this button we switch to FFT mode, and the in fact the frequency of a sinus signal is indicated here in the frequency mode. Now I set a triangular samples and feed my signal generator with these triangular signals, which we can see here, and we can see the result of its FFT, which we can see there are too many frequencies, which makes our triangular signals.